Welcome to Chapter 9, Section 2. Today we are going to now start talking about solving quadratic equations. And the first way that we're going to look at solving them is by graphing. So this is a very visual approach to solving quadratics. Now recall a quadratic equation is a nonlinear equation that can be written in the standard form, ax squared plus bx plus c. We just spent the last few chapters looking at quadratic equations, factoring them, and then graphing them. So today we're going to look at solving them by using their graphs. When we solve a quadratic equation by graphing, we follow these three steps here. First of all, we're going to write it in standard form and set it equal to 0. Next, we're going to graph that equation, and then finally, we're going to determine the x-intercepts. Recall from previous chapters, those x-intercepts were known as our solutions, or the zeros of our quadratic. So today, we're going to see that the real solutions, also known as the roots, or the zeros of the quadratic equation, are the x-intercepts. So we can visually see those solutions on that x-axis. Now, when we graph a quadratic, there's one of three situations that can occur. That quadratic, which is a parabola, can pass through the x-axis in 2 points, in which case we'd say that there are two real solutions. That parabola can bounce off the x-axis and touch it in just 1 point, in which case we'd say there's one real solution. Or finally, a parabola can turn back up before passing or even touching the x-axis, in which case we'd say that there are no real solutions because there's no x-intercepts. All right, so we're going to practice doing this today on our graphing calculator and using Desmos. So the steps here for using your graphing calculator to find the solutions of the quadratic. Here is your first example. It says to find the solutions of this quadratic equation, x squared plus 2x equals 3. Now if we follow our first step, we're going to get this into standard form by moving this 3 across the equal sign. So now we have y equals x squared plus 2x minus 3, and we are going to set it equal to 0. So now we are going to take that y and make that 0. So here is our first step. Next we're going to graph it. Now using our graphing calculator, you know how to enter that into y equals and follow through these steps here in order to get those intercepts. We are going to graph this on Desmos for the purpose of this video. So here is x squared plus 2x, and we're going to minus 3. And since it's set equal to 0 already, we are going to look at the x-intercepts. And I see that my x-intercepts here are negative 3 and positive 1. So I would say that negative 3 and positive 1 are my solutions to this quadratic equation. I'm just going to abbreviate that, a quadratic equation. Now you could check those by plugging them back in. Let's see if this produces a true statement. If I take negative 3 and square it, plus 2 times a negative 3, that should equal 3. So negative 3 squared is 9. 9 plus a negative 6 is in fact equal to positive 3. So yes, it does check out and produces a true statement. Let's try it with the number 1. I'm going to come down here. We got 1 squared plus 2 times 1 should equal 3 as well, and 1 squared is 1 plus 2 is equal to 3, and that checks out as well too. So you can always plug those numbers back into your quadratic equation to make sure it produces a true solution. All right, let's flip the page and move on to our next example. Here it says to find the solutions of a quadratic by graphing. So we're going to solve the quadratic x squared plus 2x equals 8 by graphing the quadratic on your calculator and completing the table. So remember, our first step was to write this in standard form, x squared plus 2x. And now I'm going to move the 8 over to the other side of the equal sign by subtraction. Minus 8 is equal to 0. Now I'm ready to graph this on my graphing calculator. I'm going to go back to Desmos. And I'm going to expand my example 1a. Here is my first graph. Y equals x squared plus 2x minus 8. Now remember, the y value that I want is 0. So that's why I'm looking here along my x-axis. And I see that my two solutions that passes through here are negative 4 and positive 2. So I found my solutions to equal negative 4 and positive 2. Next, I want to make sure I complete my table and just show a graph of what my parabola looks like. So heading back over to Desmos, I can turn on my graph for this function and create my table. Negative 2, negative 8, negative 1, negative 9, 0, negative 8, and oh yeah, we got some other points here. So let's go ahead and make sure we plot those. Negative 4, this was 0. At negative 2, this was negative 8. At 0, it was negative 8 again. And here we had 0. And then at positive 4, let's see what a positive 4 value is. It should be up to 16. Okay, so now we have our values here, negative 4, 0. We'll plot these on our coordinate plane. All right, and we got enough of our parabola here to draw a nice classy graph in. So there we go, we've solved it, and we can see here in our table where our zeros exist. We have them here at negative 4 and positive 2. That's when our y values were equal to 0, and therefore the x values of negative 4 and positive 2 are the solutions to our quadratic. All right, in this first part of example 1, we saw that we had 2 real solutions. In our next graph, we're going to take a look and see what happens. Solve the equation x squared plus 4x minus 4 by graphing the function on your graphing calculator. So again, step number 1 is to write this in standard form, x squared plus 4x. And now we're going to add the 4 over and set it equal to 0. All right, let's go back to Desmos. I'm going to turn off this first graph here. And let's take a look at this second graph. Here is x squared plus 4x plus 4. And you can see that this graph comes down, this parabola, and bounces off the x-axis here at negative 2, 0. So this is an example that has one solution. All right, so going back here, I have one real solution. And that one real solution is x equals negative 2. So I'm going to plot that point here on the x-axis. I believe that it passed through the y-intercept at 0, 4. And that would make that point there, negative 4, 4. And there's enough points to graph our parabola. All right. So here's an example where we have one real solution. Up above we had 2 real solutions. Next, let's take a look at our graph in example C. We want to solve this quadratic equation by graphing the function on your graphing calculator. So this time we're going to take this negative x squared and bump it over here to the right hand side. So we'll have 0 is equal to x squared plus 4x plus 8. And we're going to take a look and see what happens when we graph this one. All right, here is x squared plus 4x plus 8. And what you notice is that this orange parabola comes down and it goes back up before crossing the x-axis. So for this particular case here, we have no real solutions. All right, no real solutions. If we want to graph that, which we should always graph that. I believe it went through negative 2, 4, and then 0, 8, and then we'll cross over here. So there's enough points to graph our parabola. Nice and classy. So here we have no real solutions because it does not cross that x-axis. All right, so let's get a word problem going here, as all good math problems involve some real life scenarios. A soccer player kicks a soccer ball 2 feet above the ground with an initial velocity, vertical velocity or upward velocity of 60 feet per second. This function, h of t, equals a negative 16t squared plus 60t plus 2 represents the height in feet of the ball after t seconds. All right, so we're going to again graph this and take a look at what that graph means. So coming back here, we're going to close out of that, and we're going to enter in our negative 16 x squared instead of t plus 60x plus 2. All right, and we'll zoom out here to get a good look at the path of this soccer ball. Looks like it goes really high up in the air here, about 58.25 feet up in the air. It leaves the ground right here at about 2 feet above the ground, because that's where he kicked it from. And it looks like it comes back down right around 3.78 seconds and hits the ground again. All right, so let's go back to our notes. It says find the height of the ball each second after it's been kicked. So if we're thinking about t as our seconds, we can think of 0 from when it leaves the foot, and then 1 second, 2 seconds, 3 seconds, 4 seconds, so on and so forth. All right, well, let's go back to Desmos and create a table. When I do that in my table, I can keep doing my seconds here, but notice that I don't really want negative seconds because time can't be negative. So here is from when it leaves the foot, it's at 2 feet above the ground. 1 second, it's at 46. 2 seconds, it's at 58. And then 3 seconds, it's back down to 38. So let's copy that over to our notes here. Our y value is our height at t seconds. We said that was 2 feet, and then 46, 58, 38, and then negative 14. So it's actually passed through the surface of the earth. Estimate the height of the ball, estimate when the height of the ball is 40 feet above the ground. So a neat little trick to do with this one here is to actually just graph the horizontal line, y equals 40. And what you see here is that the path of this ball is shown in blue or purple, and the height of 40 is shown in black. And if we tap on the intersection point here, we see that it's at about 0.81 seconds, and then again at 2.9 seconds. So it says estimate when, so that's talking about time. So time would equal about 0.81 seconds, and 2.9, would we say 2.94 seconds.